Good morning, children. I'm sure you've started preparing for the Thursday's test. You will be giving the test during the Zoom class timing. Okay, so you'll be giving the test in your test copy. So be prepared, have your test copy nearby, and you have to take the test. So that's the plan. So prepare well. Right. And today we are going to start with the B part of chapter 4, refraction of light through a prism. Refraction of light through a prism. In the previous one, we saw a glass slab. Okay, we saw a glass slab that is called rectangular glass slab because it is rectangular shape. Now, this is a prism which is in triangle shape. The prism is in triangular shape. Okay, so it is actually a three-dimensional thing. You can imagine it like a pyramid or a tent house. Okay, so if you imagine like this, it will have three rectangular faces, 1, 2 and 3. These three rectangular faces and two triangular faces, this and the back one. So three rectangular and two triangular faces, and then this angle is called angle of prism. This angle is called angle of prism. So now we are going to see how the ray gets refracted in a through a prism. Okay, so refraction through a prism. Now remember, as I am doing this, I want you also to do it along with me. Okay, so please take your pencil and scale and draw the diagram along with me. That will help you to understand better. Okay, so first, so you draw a triangle. Okay, prism, we don't, when we take a cross section, it will only be a triangle. Okay, so I'm drawing another one. That's triangle is not proper. So okay, so this is the triangle. You can name it A, B and C. This is the angle of prism. This angle is called angle of prism, angle A. Now take an incident ray coming in this direction and hitting this surface AB, and at this point you have to draw a normal. Be careful, this line has to be at 90 degree. Some are drawing like this, some are drawing like this. No, you can approximately, you know how 90 degrees should be normal line, right? So this is your normal. Then the ray should have gone like this, but you know that this is air and it is entering into glass. So rarer to denser, the ray will bend towards the normal. Okay, so original path. So you should draw the refracted ray between incident ray and extended incident ray and the normal. So your refracted ray will come like this. Is it clear, children? The ray has to bend towards the normal, so you will get a refracted ray like this. Again here, at this point, again you draw a normal. Again make sure it forms 90 degree, and then this should have been the original path. It should have gone like this, but because of refraction, it's coming from a denser to rarer, so it will bend away from the normal. So you will have a ray like this. Okay, P, Q, R and S. Okay, then the angles. This is angle I, angle of incidence. This is angle R, angle of refraction, and this is angle E, angle of emergence. So in the side you have to do the labeling. Okay, so PQ incident ray, QR refracted ray, and RS emergent ray. Then angle I, angle of incidence, angle R, angle of refraction, and angle E, angle of emergence. Okay, so this is the main diagram, children. So there's another angle called angle of deviation. Okay, now imagine if the prism was not there. If the prism was not there, this ray just would have gone straight. This ray would have just gone straight like this. Now because of the prism, it bent once here and again here, and it is going in this direction. Okay, now if I extend this emergent ray, this is the final ray, so I extend the emergent ray backward, and then I extend the incident ray forward. So the ray should have gone like this, but it is going in this direction. So whatever is the angle between the extended incident ray and the emergent ray, that is called angle of deviation, and it's represented by del. Okay, del is called angle of deviation. Why this name? Because it gives how much the ray has deviated from the original path. Okay, this was the original path and it has deviated by this much angle and it is going in this direction. Okay, children. So this is how refraction through a glass prism will take place. Okay, so if you look at your book, the angles they have given are quite confusing. R1, R2, del 1, del 2 and all. Okay, so you don't need all that. So this diagram, if you please draw it neatly and always study from the notebook. You can write here and keep study from notebook. Okay. Okay. Then now we go to the theory part ahead. So basically in a prism, the ray will bend towards the base. We can say the ray that was going, this is the base of the prism. The ray that was going like this will always bend towards the prism. It was going away from the prism. Now it will bend towards the prism. That is the function of a prism, we can say. Simple way, function of a prism. What does a prism do? The ray bends towards the base of the prism. That is what a prism does. Okay. Next is define angle of deviation. Definition of angle of deviation. Other angles are familiar ones, but angle of deviation is the new one. So the definition will start from here. The angle between the direction of incident ray, OP produced forward, and the emergent ray. Okay, incident ray and the emergent ray. You don't have to write all this. Incident ray and the emergent ray is called angle of deviation, and it is denoted by the Greek alphabet del. Okay, so this you have to memorize, and then you don't have this derivation, only the conclusion is needed. So you can strike off the derivation. Till this you can strike it off. You have to remember this conclusion. Now what does this equation say? So in the diagram we saw there are four angles, I, R, E and del. Now all the four angles are related together through this relationship. Okay, so I've given the name as relationship between angle I, angle E, angle A and del. Actually there are five angles. Angle A is angle of prism. Angle A is angle of prism. Okay, so this relationship is between four angles. So angle of incidence plus angle of emergence is equal to angle of prism plus angle of deviation. Just have to memorize this. So if they ask you relationship between angle I, E, A and del, you have to write this. R is not there. Angle of refraction is not there. You just have to remember this. Angle of incidence plus angle of emergence is equal to angle of prism plus angle of deviation. Okay. Now here we have another important concept. Now if you compare the refraction through a glass slab and refraction through a prism. What's the main difference? So in a glass slab also you had like this, ray bent towards the normal, and then here ray bent away from the normal. And what did we see? That emergent ray will always be parallel to the incident ray. So extended emergent ray will always be parallel, and this is called lateral displacement. This is called lateral displacement. Now, what about angle of deviation in this? In this, angle of deviation is 0. Why do I say that? Because if I extend the incident ray and the emergent ray, they're going to go parallel, and you know parallel rays never meet. And what's the angle between parallel rays? 0. Okay, so basically what does a glass slab do? It shifts this ray, which would have gone like this, into this position. Just there is a perpendicular shift. There is no angle deviation. The ray that would have gone like this, the ray that should have gone like this is shifted like this, and it is going like this through. Okay, there is some perpendicular deviation, but there is no angle of deviation, or you can say angle of deviation is 0. But that is not the case with the prism. Okay, there is an angular deviation. Okay, so there is an angular deviation between the incident ray and the emergent ray. So the angle of deviation is there. For this, angle of deviation will be 0. Okay, so this is given in this paragraph. The question can be, how does refraction produced by a prism differ from that of a glass slab? How does refraction, okay, not refraction of light, okay, RL, reflection of light produced by a prism different from that of a glass slab? The answer will be, in a prism the refraction occurs at two inclined faces. Okay, here a refraction is occurring at two inclined faces. Okay, here it is occurring at two parallel faces. That's the main difference. Two inclined faces. So the emergent ray is not parallel to the incident ray, but it is deviated towards the base of the prism. Okay. On the other hand, in a parallel sided glass slab, the refraction occurs at two parallel surfaces. So the emergent ray is parallel to the incident ray, just with a lateral shift. Okay, children. So this is another concept that you have to remember. Next we go to, so angle of deviation is the new thing or important term in this. So we are going to study a little bit in detail about it. So what are the factors affecting angle of deviation? Factors affecting angle of deviation. There are 4 factors: angle of incidence, material of prism, or I can say refractive index of prism, angle of prism, and color or wavelength of light. Angle of incidence, refractive index of prism, angle of prism, and color or wavelength of light. As usual, you also should know how it affects. Okay, so for angle of incidence, it's little bit it's an detailed one. For these three you can just remember, it is directly proportional, this is also directly proportional, and this is inversely proportional. Okay, angle of deviation is directly proportional to refractive index, angle of deviation is directly proportional to angle of prism, it is inversely proportional to wavelength. Okay, if you want to know the explanations, usually they don't ask the explanation, you can go through this. Okay, directly and inversely. Now, with angle of incidence, it's both direct and inverse. Why do I say that? For some time, it will have a direct relationship. For some time, it will have an inverse relationship, and then it will have a direct relationship. So, it's a very unique type of relationship. Usually, either it will be direct or inverse. In this case, first it will be inverse, then it will be direct. Okay, so this is the graph that shows the relationship between angle of incidence and angle of deviation. Angle of incidence I, angle of deviation del. Now you just remember the shape like U. Okay, something like a U shape. Okay, so what does it mean? So till this point, as angle of incidence increases, angle of deviation decreases. It started from here and then it's coming down and down and down. So till this point, with increase in angle of incidence, angle of deviation decreased. That's why we say here it is inverse relationship. Now, beyond this point is called del minimum, angle of minimum deviation. Angle of minimum deviation. Now, beyond this point, with increase in angle of incidence, your angle of deviation starts increasing. So, you get a graph like this. That is a direct relationship. Till this, it was inverse relationship. After this, it is direct relationship. Okay, so this is a very unique behavior, and this graph keeps coming very often. What is the relationship between angle of incidence and angle of deviation? Show it by a graph, and so you have to show it. Okay, so that's given here. As the angle of incidence increases, angle of deviation first decreases till it reaches a minimum value for a certain angle of incidence, and then on further increase angle of incidence, angle of deviation begins to increase. And then this graph. Okay, now there is one thing called angle of minimum deviation. Okay, there is one position, or there is a particular angle of incidence for which the deviation will be minimum. The deviation will be minimum. That is called position of minimum deviation. Okay, position of minimum deviation. It's like basically you're changing the angle of incidence. Like an incident ray that is coming like this, you're starting, okay, first you took that ray here, 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 and all that. For one point, okay, at one point as I was increasing, initially it was decreasing, angle of deviation was decreasing. At beyond one point it started increasing. Now that point, which is the smallest one, this is the lowest point, that is called angle of minimum deviation. Now in that position, two things you have to remember. Whenever the deviation is minimum, okay, whenever it is minimum or del minimum I say, then there are two conclusions I can get. One is refracted ray will be parallel to the base. Refracted ray will be parallel to the base. And second one, angle of incidence will be equal to angle of emergence. These two angles will be equal. Okay, so the question could be, what are the two conclusions in minimum deviation position? What are the two conclusions that you receive in a minimum deviation position? First, angle of incidence is equal to angle of emergence. Angle I is equal to angle E. Second one, in the position of minimum deviation, refracted ray inside the prism is parallel to its base. Now children, in this diagram, it's already parallel to base. That means it is in minimum deviation position. Now actually, the diagram need not be parallel to the base. See, I have drawn another diagram here. Okay, so it won't be always parallel to the base. Okay, only in minimum deviation position it will be parallel to base. Otherwise, it will be any other. It will be in a different direction. Is it clear? So that position where refracted ray is parallel to base is called minimum deviation position. And then what happens to this equation? What is that equation? Angle I plus angle E is equal to A plus del. But these two angles are equal. In minimum deviation position, angle I is equal to angle E. So instead of angle E, I write angle I is equal to A plus del. So 2 angle I is equal to A plus del, or angle I is equal to A plus del by 2. Okay, or that's one way of writing if they ask you angle of incidence. The other conclusion that you can get is 2I is equal to A plus del or del minimum. This is possible. So when this is equal, I have to write del minimum. So del minimum will be 2I minus A. 2I minus A. Okay, so that's what is given here. So this graph, and then the two conclusions in the minimum deviation position, and then this is the explanation of the graph. These are the three things that you have to study in angle of incidence. Okay, so this is how the relationship is. And again, you don't have to do this. You can just strike it off till this. Come straight here. Okay, more the refractive index, more will be the angle of deviation, and then more the angle of prism, more will be the angle of deviation, and then more the wavelength, less will be the angle of deviation. That is what inversely mean. Okay, so if it is violet light, okay, wavelength of red is more than wavelength of light, violet. Wavelength of red light is the greatest always. Okay, we know, violet, white light is made up of the 7 colors, and out of that wavelength of red is greater than wavelength of violet. So red will undergo less deviation and violet will undergo more deviation. This you will be studying in the D part. Okay children, so with this my teaching part is over. Now quickly I'll give you the homework for today. You can just finish it as soon as you listen to this lecture. Try to complete them. It will be very easy. Question number 2, 12, 13 and 19. 2, 12, 13 and 19. Okay. So for 13, the answer is there here itself. So maybe you don't have to do that, but please read through it and try to understand it. In your notebook, I don't expect this. Okay, so notebook 2, 12 and 19 alone. Okay, now for explaining 19, to do 19th, I need to give you one more explanation. Now, so what does a prism do? It bends a ray towards its base. Simply, what does a prism do? It will bend a ray towards its base. This ray which would have gone like this, it started going like this. Now, if I keep the prism in the opposite direction, okay, and allow this ray to hit here, if I allow this ray to hit here, it will again bend towards the base and go like this. Okay, I keep two prisms, one like this, another one like this, one with base here, other one with base at the top. Okay, so now this is my incident ray. So refracted ray, emergent ray. Now the emergent ray will go and hit here. Now this becomes the incident ray, and this will become the refracted ray, and then this will become the emergent ray. Sorry, the normal will be like this. Okay, this will become the emergent ray. So it will be finally, if you see, the emergent ray will be parallel to the original incident ray. Okay, what they say is these two prisms, it's like I combine together, they behave like a glass slab. See, these two prisms, if I attach, it will become a rectangular glass slab, and in a glass slab, you know what is happening? Lateral displacement is happening. That is what is given in these two diagrams. So here the 19th question is based on this. You can do that. Then there are some numericals based on del minimum. That's very simple. You can try that also. So once again, a reminder, please prepare for the test thoroughly, and when you are attending the Zoom class, sit with your test copies and do your test sincerely. Thank you so much.